One of the most common questions I get on my videos on the channel is that how one can run these large language models on commodity hardware such as CPU or entry level GPUs. These LLMs are of huge sizes and they require a lot of RAM and VRAM. Not everyone has the resources to arrange for this high end computing, and not everyone can pay for these huge cloud resources. So if you're looking to run these LLMs on your commodity hardware, then I'm more than sure that this video is going to help you. So stay tuned. As you can see on your screen, I'm already logged in to my entry level laptop, and I'm running Ubuntu, and my Ubuntu version is 22.04. So what I'm going to do, I'm going to show you how you can shard or break down an LLM into smaller pieces so that each of smaller piece would be able to offload to our different CPUs, or even if you have entry level GPU, it should offload some of it to the GPUs automatically. So sharding is a technique through which we break down a large language model into smaller pieces, and then we run those smaller pieces on our different CPUs or CPU threads, or even we can offload it to the GPU. Okay, now let's get started. The first thing you need to do is to install some of the prerequisites. Now these prerequisites are pretty lightweight, so you don't have to worry about much. And let me paste these prerequisites here. Let me first clear my screen. So the prerequisites are sentence piece and accelerate package. Both of these modules, accelerate is the main one, so because it is used to shard the model. So that is installed. Let me clear the screen, and now let me fire up my Python interpreter. That is there. First, let's import some of the packages from the modules which we have installed. So here you can see that I'm importing tokenizers from the Hugging Face. That's done. And now let's specify our auto tokenizer for this flan T5 large model, which is from Google. It's a lightweight, so but you can use these same commands with the proper tokenizers for any other model. This is done, and now let's go with our model. So this is the model we are going to use, and the size is just under 4 gig, and we are even going to shard this model. Let's wait for it to finish. That's done, and now let's import our accelerator. This is our accelerator, and now instantiate a client of this accelerator, which we are calling again accelerator, and you can name it anything, this left hand side one. This is done, and now let's give a model path, which could be any path on your local system. So I'm going to call it home Ubuntu and model. I already have created this directory there. That is done, and now let's save the model to the local directory by sharding it in 1 GB slices. So there you go. So we are simply saving this model, the model which we have downloaded above. This is the directory which we have just specified, and we are saying that each piece of this model would be 1 giga. You can ignore this warning for now, and that is done. So quick. Now once that's, let's load the checkpoint and dispatch. Let's wait. So this is where we are importing it. That's also done. And now let's specify our CPU. We are not even using GPU here, so let's go with the CPU. And now let's load our model with the proper checkpoints. Let me paste the full command instead of typing, and let me say model colon checkpoint is equal to, and this is a path where I want to save my model slash, and then double quotes, and then simply the blocks, the device maps which we have just specified. That's also done, and now let's do some inference on the sharded model. I'm just going to ask it, let me ask it, why lion is king of jungle, maybe question mark, sorry. This is better now. And now let's pass this input with to the tokenizer. And this is the usual stuff which I have already shown in a lot of other videos which you can check. And now let's ask model to generate the output. Let's press enter, and that is already done. And now we can generate the sequence tokens from there, and then also we can print the output. But let's generate the sequence tokens. Okay, I think I just need to paste it again. Sorry about that. So this is a token sequence, and now let's decode that token, the output token I mean, from the model. That's also done. And now let's see what model has generated after decoding it. There you go. The response is he is the most dangerous animal. And then you can maybe do some more stuff here. If I go up again, then you can maybe I'll try it out. You can say, what is the capital of Australia? And then you can send the input again here, and then also the output true. And this, let's generate the sequence token again and obtain the decoded generated text and print it. There you go, Melbourne. Totally wrong answer. But this is a very lightweight and experimental model, so don't worry about the output. The main thing is that this is how easy it is to slice your model into small pieces, and you can control this size. So here we have specified 1 GB. You can do it like 2 GB, 4 GB, whatever you like. And if it's a huge model, then just balance it out as per your number of CPUs. This is it, guys. In the next video soon, I'm also going to show you how you can slice or shard the mixed role model, which will be very interesting, because one thing you need to take care is that for this only if it would show me. Okay, so here I am using this T5 for conditional. This is only for this model. This won't work with any other model. So you would need the proper tokenizer and proper T5 for conditional generation for that specific model. So in the next video, I'll be showing you which conditional generator or tokenizer to use for mixed role one. So that's it. I hope that it was useful. If you have any questions or if you're stuck anywhere, let me know and I'll be happy to help out. And if you like the content, please consider subscribing to the channel. Thank you very much.